Welcome to my channel opensource.net. In this video, you are going to learn about C# records. Records were first introduced in C#9. Their key properties are concise positional property syntax, destructive, non-destructive, mutation, immutability, destruction. So you will learn about all these features. But before that, let's look at some code like if we don't have records, like we live in .NET Framework world, or we are stuck with C#8. I have written a very small code. I have a class name. So it's a first name and last name, like anybody has a name. Then I have an abstract class person, and person has two properties, name and age. And then there is a class student which inherits from person. It has an ID, it has a country, and then in the constructor I am initializing all those properties. If you notice that usually most of the time before C#8, I guess C#7 had the only getter and setters for a very long time. If that was the case, here I am creating a new student. I'm providing all the inputs, and here I am passing the name. Let's refactor that into a variable, and you know what, just one name of noun, and here I'm gonna say name of Adnan from Boston. So what do you think what this code is doing? I'm asking a simple question, that this is a student name, and this is a student, and this is student name. All I want to find out, do they have same name? So what do we do? So naturally what I would do is Adnan, that name, which is a type, and equals Adnan from Boston.name. What do you think this will print? Let's run it. No, it did print no. If you guessed right, if you already guessed it, like it is going to print no, good for you. But why did it print no and not yes? Because when we are comparing here, it is not comparing the values. That is why it is comparing the references, and they are two different objects, if you see here. But what if I do pass name of Adnan here, and this will be unused? What do you think is going to print this time? Yes or no? Let's find out. It said they have the same name. But why? Because they are pointing to the same object. So this comparison here is happening. It is comparing the references of these two objects, which is of course the same. But if we pass a different object here, although they both have the same first name and last name, but we cannot get the correct name in here. So how do we achieve that? Before C#9 records. So one way is that C# has an equatable interface. I'm just gonna generate the equality members. The writer has very nice feature. You will see it will implement. I can even say that Arduino is just gonna keep that for now. If you look here, the interface itself has one implementation equals to other, and then it also overrides the other method equals, and it overrides the get hash code, and it overrides the operators as well. So now we have implemented the equality. Now whenever we're going to call equals, it's going to come here and see if these two objects are the same or not. So if we're going to run it this time, if you look here, reference equals return false. Here we are passing the null true. If they have the same reference, of course there is going to be same. But here we're comparing both the values of the first name and last name. If both the string values are same, it returns true. So here you can see I'm passing in creating one object of the name and then another object. Now if I'm gonna run it, what it will print? The answer is yes. Because let's debug it a little bit. Oh, I didn't click on the debugger. So we come here. So it's null. No, nothing is null. It's gonna go here, this and this. Are the references equal? No, references are not equal. But the first name and last name are equal. So we're gonna print yes. While we are at here, it is usually a good practice the one advantage of introducing a variable here is that then you can, when you're debugging, you can see what this expression actually outputted. Otherwise you will have to do it in an immediate window otherwise. Let's get back to the topic. So now we understand that how we can implement value-based equality, not the reference-based equality, value-based equality, in the world where there are no C#9 records. Now let's roll it back. But if you say that I need this feature, but I don't want to implement all this equatable interface implementation every time I create a class, or I create a reference type, and I demand value-based equality. So here comes record. You can say record, and it is saying that it is unnecessary, but we're just gonna keep it for now. Let's run it. What it's gonna print? It's gonna print yes, but why? So it printed the yes. So why did it did that? Because C# compiler automatically generated the equatable implementation for you. You can look at it. My key is code tools. Where is the IL here? Okay, let's go look at the code it generates. The writer has this really nice feature where we can look at what the code will be generated by the compiler. So we are at the records. You can see here that it is implementing a getter and setter for the property here. And you can see that overwritten the hash code, and then it also overwritten the IEQ table. And you can see some additional code as well. So there is a lot of code that it has implemented the clone, and you see it has implemented the print members for you, and which is getting used in the toString as well, which is nicely formatted. So all this is generated by the compiler. So now we know why when we are running this example where we are passing two different objects, name of Adnan from Boston and name of Adnan from Pakistan, and it is printing yes. So this is value-based equality. But notice that all the code we have written previously in the class using IEQ table is gone now. In fact, this can be gone as well. And here we're gonna say what you were saying, generate the constructor. Well, you can simply have the bracket like this: string first name, string last name. That's one, it's still gonna work. So it printed yes, because behind the scene the compiler has generated all the code for you, and you get the value-based equality semantics in reference types, and it is really useful. This makes your code very readable. This is very nice and concise syntax. It's literally one-liner, and it really shines when you have true value types. For example, the name of the person is a true value type, because when you compare the names, first name and last name is the same, the result should be always true. Here is an example that, okay, we want to see if there are two students and do they have same name, and it is giving us yes. Now, if you notice previously, I'm just going to do Command Z. So I had the public setter in here, meaning I could say, let me generate the constructor so this compiler won't complain. So notice here, name of Adnan dot last name is Ali. So it is not complaining. So if you go to C# documentation, immutability is one of the top features of records, and they're by default immutability, just like strings. Strings, whenever you assign a value, always allocate a new memory. Here, immutability means that the object, whatever behavior or properties it have, once created, you should not be able to change it. So you are sure that whatever you're passing down the line, it is, if it is the same reference of the object, the values will always remain same. Let's just remove that. Not remove that. Let's say that we want to make it init only. So if you notice above now, the compiler will start complaining that no, you cannot change this value. Can only be assigned in object initializer or from the class itself. What object initializer? It usually means this. I can say a new name here, and since it's have a constructor, so we have to like that. This is object initializer. But we are specifying it by ourselves. We can remove all the syntax and go back to simply saying string first name, string last name, and the compiler is still complaining that you cannot change the value of this last name because it is immutable out of the box. Because if you look at the IL viewer again, hopefully it is here. So if you see here that it is init only property set generated by the compiler for you. So that gives you out of the box immutability, and we already discussed how the value equality semantics work. Now let's dive into that how the non-destructive mutation works. So say that we have the name of Adnan, and I just want to change the last name and copy the rest. So I can say that last name Muhammad, name of Adnan with different last name. So if we print this, name of Adnan with different last name, and thus print the name of Adnan as well. So what do you think what's gonna print here? Let's find out. So if you see that it printed a really nicely formatted string here. Name, first name is the type of the name, last name Rafiq, and then on the second line we are saying first name and last name is Muhammad. So if you notice here, we only assigned change last name, but we didn't change the first name. So it did copy all the data from that type to this object out of the box, and this is done with the code generated by the compiler for you, which is a really nice feature. If you are dealing with some objects where you want to mutate it, but you want to only change certain properties but not change all of the properties of that, like we are doing here. So this is called, and if you notice here that the first object here is unchanged, like the name of name of Adnan, last name of Adnan is not changed at all, meaning it is totally unchanged. And we can even say, okay, let's find out, are they reference equal? Object 2, name of Adnan from Boston. So what do you think you're gonna print? Let me tell you, false. Because they are two different objects pointing to different place in the memory. So it's reference type, support the value equality semantics out of the box. You can copy the data from one object to another and change it if you like to. They print a really nicely formatted string as well. So immutability by default, value semantics by default, nicely formatted string by default, and on top of that, this is really nice syntax. And it also conveys conceptually that this is a reference type. It supports, if we look at the name here, you can see that it's an internal record, and now the writer is fetching the documentation automatically. It does implement immutable, which is really nice. So when you're reading the code and you see that, okay, it is record, but if people are saying, okay, it's value-based semantics, is it struct? and you have intentionally declared it as a record reference type. C# then has this feature called that you can append class to the record. If that's what your team want, great. You can adopt this approach and change the settings in the writer or whatever in Visual Studio or VS Code, that stop complaining about it. And conceptually, you will be on the same length. That okay, we got a record reference type which supports value equality semantics out of the box. Now, there is another nice feature which we can achieve in class 2 by implementing a static method to deconstruct using the out variables. Let's see how the records does that out of the box. So say that you are into a method and you don't want to use let's say I want to print the first name in one line and the last name in the next line. So what I would do is name of Adnan from Boston, first name, right line, name of Adnan from Boston, last name. So it will print it, but you notice here that you are using the dot notation to assess that. So we can use this feature here. I can just say name of Adnan from Boston and first name, last name. So it will automatically, you can see here that first name. So all that long name, which in your team might not be readable, and you like to have a short and still meaningful names, especially when you get an object passed to a method and it has like 3-4 properties and you don't want to access those properties using the dot notation everywhere, especially when they are used at multiple places. So the best thing to do is deconstruct it like this, and you get the string variables right there and then. And I'm just gonna run it for the sake of it to see what they're gonna print. They're still gonna print everything what we expect to. So see that the non-Rafiq printed twice here and here, which is cool. So 4 features. Top of the line, very nice syntax, concise, positional properties, first name, last name. These are called positional because that's how compilers is gonna generate the positional properties. It's gonna be first name and last name. Value equality. A name is a type and it is equal to another name from another student because compiler automatically generated the equatable implementation for you. Non-destructive mutation, where do we do that? Over here, yeah. And the with expression is really nice in that sense. Deconstruction, we just did that. So no matter how many properties you define, it is going to deconstruct it for you. So we learned about all these 4 things. How about some of the missing features are where they don't really shine? So let's try to add some behavior to the name. Say that I just want to print the initials. I don't want to print the full name, especially you mostly notice that on the sides when you are signed in on the top corner, it does print only your initials, not the full name. Maybe the presenter is presenting and they don't want to expose their full name. So how do we do that? So here we can define a method, public string initials. We already have first name, last name, and I can just return last name as span 0 character, and then I can here say first name you notice that now as soon as we added the behavior, that doesn't mean that we lose anything. We didn't lose anything. It's just that now the curly braces of the record, which are necessary for to have any behavior in classes, and same goes with the record as well. You still get a lot of benefits out of it, but as soon as you start having behaviors, they will start looking like a regular class. But they shine here because name is a true value object. It does not have any identity. In domain-driven design, value object is a special concept that they cannot exist without an object who has an identity, who has a life. Like it gets signed a ID, you can identify by that, and then it has behavior and some attributes. And one such attribute is a name, but name does not mean anything unless it gets attached to a student. So in that sense, even we are adding some behavior here. I'm just trying to format it nicely. So let's try right line, none from Boston. So we have the name here, and what we have here, initials. I implemented as a method. Okay, let's see. So you can see here that it is implemented the array. The rest of the functionality is still the same, the value equality semantics, and among other things. What else we can do in records? Anything literally you can do with classes, you can do with records as well. This board inheritance as well. So I can make this record. What did I do? To see a substruct, I can say record class. Here it is complaining because I made it. So see here, everything is still nice, but they all support value-based equality and value object semantics to a degree. But since student is not really a value object, we should not probably do that. Unless we can do that, but it's just to show you that it does support inheritance. Let's go back and let's try to make a name a little bit more complex. So what I'm gonna do is I'm gonna say string, and here I am going to say nicknames. You might have noticed that people have many nicknames. Your friends call you something. My friends call me Dani, and your family calls you something. My family calls me Sahib. Sometime your wife might call you honey or whatever. So what about now? So it is an array. You have multiple nicknames. What you doing? So here I'm gonna use new, and I'm gonna say Dani, and here I'm gonna say Sahib, nicely formatted, and here just to make it happy, I'm gonna say Dani here, just Dani. Okay, so name of the Adnan. Now let's say there is another Adnan, but it has only one nickname. Okay, so right line name of Adnan equals name of Adnan with different last name. Yeah, okay, let's see. Right line, just gonna do that so we can see that, you know, we are printing here. Are you guessing? So what's gonna print? Probably print gonna say, well, what is that? It is complaining here nicknames. Okay, it did say false. Of course it would say false because nicknames are different, right? What about if we say like that? What's gonna print now? Bill has succeeded. That's correct. Still false. But why? They have literally the same nicknames. Why would it print? So what happens here is, although string is also a reference type, it allocates on heap, but it's immutable by default. So to generally say that this is a shallow comparison, that these nicknames, since it's an array, it's a reference type, they are compared by references, not by value. And one can say, okay, yeah, okay, it's a reference type, then string is also a reference type. Why did it not complain then? It is because the strings are immutable. Whenever you change it, it's allocated once, and it cannot be changed. There has to be new string allocated. So that is why it is complaining. So we can make it happy only if I... So this is a missing feature in records, and maybe hopefully .NET team is very talented. They will figure it out if it is make sense in the long run. But I think this should be there, and probably with some nice syntax to let's just replace nicknames. Okay, just to make happy and make a point, right? It is complaining because we have a nicknames down of how about now? Good. Let's run it. Oh, because I gave it the different name, so that is why it was printing it. Okay. Let's just do that then and verify our hypothesis again. I might be wrong about so it's printing true, but just for the sake of it, I'm just gonna here say something like that. Hello. Of course it's gonna print. So let's just first with empty string, let's print false. False. And I'm quickly gonna type Dani here. Are you happy? Still false. So it is confirmed that if you have a reference type like arrays or another object, then it is going to enforce reference type equality, not value based equality. I mean, we can solve this easily if we can define another type of nicknames. So let's just assign it a nickname back, nicknames of Adnan. So it will be happy now. It should print true. See that? True. Okay. So how we can make it happy? Since Rakesh does not support value-based equality if you have a reference type inside it. So what we can do here is going the full route of implementing iEquatable ourselves or overriding it. Since it's a true value type, it's a name, we can make record nickname string name. Okay. And here, instead of saying it's nickname, we can say nickname. Okay. Why you are complaining? What's the problem? Nickname is never changed. Okay, that's fine. Don't worry about it. So here we can say new so it is saying nicknames of no. So we can, there is a new kid on a block. We can say nickname like that, and we don't need to say that, right? Let's just get rid of that, right? And then it should have been referred new nickname. Okay, here, why you are complaining? Simon is not assignable to parameter type nickname. So what did we do? Okay, like that, right? Are you happy now? Yeah, it is happy. Let's just say are you still complaining somewhere? I don't think so. Let's just run F5 and see what does it look like now. Still printing true. So we conquered the value-based equality again, and we still got nicknames here. Nice. I mean, nickname is sort of a true value type as well. You never know that there is a business requirement down the line that a person can only have a nickname which is more than 5 characters or whatever, so you can enforce that in here and it will be well encapsulated. Okay, so that's with the value equality. Another route you can go is you can as we looked briefly into in the start of the video, that you can implement iEquatable by yourself and then compare all the values of any type, or you have full control over there. That is also very nice, and we have been doing that for years whenever we need it. It's just that the C# has been C# has been dropping features very quickly, in fact, and they are all nice features. and very usable. It looks code more, it makes code more readable. And here as well, look at the age, you know. So what if I want to find out, so age is a value type. It is, what if there is a requirement that I need to find out that if are you minor? So how do we do that? So that there is some behavior to age, we can instead of having a int type, which is a primitive in C#, we could opt to implement value-based equality using C# brackets if you are using C#9, and add some behavior there that, okay, so I can say age here. Let's look at create type. Yes, it default to record struct. Okay, and int age, right? Why are you complaining? Let me build it. I don't know why it is coming. Age, name, number of names cannot. Oh, okay. So it is. I can say. So age. So here is another nice tip. So age is usually mentioned by years. So we can say, instead of saying just age or just saying value, and whoever is using that type will not know that do you mean months, days. So it's a nice way of saying, I can make it more clear by saying that, okay, age and years, that's what I can think at the moment. So I defined a record of, so here we will demand that age here, and I can implement method here is minor, just I don't know the spell of minor, so this is a kid, less than 8, right? You can have this teenager, right? And I can say engineers 12, 13, right? Greater than 12 and R 20, right? Looks cool. What it is? I'm sure that's, yeah. So yeah, really nice, very cool. So now we got a person age. Is still complaining something. Let's find out where it is complaining. So we are assigning an age here. So we will change it to age. It will come. Okay. Huh. So well, I am 40, maybe 41, right? So let's just skip one here and here say 41, and nice. So now I can easily say, okay, what if I want to know, are you a teenager or not? I can say, are you a teenager? Name of okay, Adnan dot age in year is a teenager, right? But it's gonna print true. Are you a teenager? Yes. Not anymore. So yeah, you can still have value-based equality and encapsulate your behavior with a nice, concise syntax. So very readable code. What else we are missing here? Let me think. Yeah, one thing is the EF code does not yet support mapping records with your database tables. So that's kind of a drag. But yeah, if you are into Dapper or something, then you're fine as well. And where else? Records shine. They shine in, like, you can use it in the, if you're passing a value as a parameter with multiple properties, like a context data, which has, you know, ID, and then has like a student school ID and student age, and you set it like context data, and you are passing down to a method. So you don't want to introduce too many parameters on the method, and you want to enforce some behavior that here we are saying age, but we can simply say, okay, in that, you know, and this name cannot be null here in the person, and in the person itself we can say, in the name itself we can say that name property itself, the first name cannot be less than this many characters and all that. So you can define records for that. Or if you are fetching some data from the database and you don't want to fetch too much, and you are mapping, transposing over or mapping over to another object to pass it to define some logic, records are one-liner in that case. I mean, they have many use cases. One of them is, you know, you don't care about value equality there, but you don't want to go and define a class with nesting, and, you know, you can just have a method there. And then tuples are also nice. They have similar semantics as well. They support value equality, but they are good only for when you have like 2-3 values returning from a method or passing into a method, and you don't want a name. You don't know the name of their unrelated data. They're really good in that. But, you know, when you want to have a type name which people understand what it means, and, you know, what kind of data it represents and what kind of behavior it can have, then records is your best bet. Out variables are also similar in a way that they are used to return multiple values, like, you know, try parse. Pass in a string, like int try parse. So int has int try parse. See, is returning true, but it also returns the results, you know, whatever the int is. So these are, but, you know, only implemented it in patterns like this, the out variables. Well, I think we covered everything about records. I would love to expand on the record structs, which are in C#10, and required members a little bit more in the next video. Till then, take care of yourself, and I really appreciate you watching the video. If you like it and have any feedback, put in comments, reach me on Twitter. And it looks like you don't want to subscribe? No? Really? Okay. It's your choice. But I will love you have on board. Thank you very much.